Okay, we'll get back on these cases here. So it's a knuckle motor. What year is this thing? 47. So it broke a rod or something in here, so it dug in real heavy up in here, and it ate all this all out through here, so I gotta fix all that. The biggest problem right now, we got cracks, pretty big cracks everywhere. So we got a big crack going through here. So another one goes all the way down to here. And there's another one that goes down somewhere through here. I know there's a crack there. I don't know what this mark here is. So we got this crack right here. Got another crack going right through this bolt hole. This one comes down through here. Looks like it goes down across here. I'd rather not weld on that number if I don't have to. So the crack looks like it stops about right here. So we'll see. So this one here comes right down through here, it looks like. We got one here, one there, one there. Whoop, there we go. 1, 2, 3, 4. This whole thing is all broken out through here. So usually what you wind up doing is just cut all this stuff out and start over. It's easy how you do it. So we're going to grind out this big one first, and then we'll see how many of these little ones come up. But pretty much you got to just cut it all down and start over. That hole looks good. So this case over here, there's a big ass crack right there.
Hi Scoobers. What's up?
Alright, we're back. Interruptions. Alright, so I marked up a few of these marks, and the cracks are pretty bad. Worse than I thought they were. So this looked like the bad case. This case wasn't too bad. It's actually the other way around. This one here is the bad case, because the crack goes a lot further. So this crack goes all the way down through the number, down to here at least. And I can't tell if it's going past that corner. When it goes past this corner, you're really getting bad. And this one here, it's all blown out here. Really see on this side right here, there's also a crack going right through here that you don't really see, but it's there. Can't see it from this side, but it's there. And then there's another crack right here. You can see one right there that you don't really see over here. More interruptions. Alright, back again. More interruptions. Getting interruptions today. Alright, so like I said, this one here, the crack is pretty deep. You can see where it goes all the way down to here. And I don't know if it keeps going or not. This is a bad casting area, so it's really a porous casting, which is really common in these old cases. So it looks like the crack is stopping right here at the fillet. But if it goes further, it gets into this main bearing, it junks the case out pretty much for you. But the problem with welding this case is like welding a big bill. The cracks just go whoosh in circles, and you're chasing cracks all day long, and sometimes they go this way. It's really, really a pain in the ass. So you gotta be really, really careful when you start getting cracks, but to get it all the way down this deep, it can turn into a big can of worms really, really quick. So, and this is all blown out through here, but that's self-contained, so that's not too hard to fix. This is another crack here. Like I said, when you put heat to this case and start warming up, these other cracks are going to open up. It looks like there's another one right here also. I can see a little bit of one kind of right there a little bit. So, like I said, it will become more of a mess as we go. And this is actually pushed this way a little bit. You can tell by how the lip is not even right here. See, this is lower than that. That means that side's moved out. So, that's bad. This one over here, it's got cracks everywhere also. So you got this big long one that goes through here. I'm not sure how deep it goes. It's cracking down that hole, which is no big deal, because that's only on that hole. This one's cracked right through here, and it goes down, and I can't tell if it goes sideways or this way, or maybe it goes both ways, I don't know. And you got a crack here, a crack there, a crack there. That are obvious cracks. So you got this right here. You got a big long crack, where this whole thing's been pushed out. And this got a big gouge, so yeah, this whole area through here is pushed out. That's why it's got all the spider cracks in there. So this needs to be welded up and moved back. Then you put the case on here and weld all this up. So you got to watch what you're doing when you're welding these things, how things are going to move. And So you got cracks going on straight here. Like I said, that I'm not sure if it's a crack or not. That's definitely a big crack. And there's no cracks in here that are normally cracked. And this has to be welded back up over here where it's all eaten away. But I don't see any cracks in any of this stuff. It's a plus. So normally what you do is you bolt the case together. Yep, they will bolt together. Kind of pushed in there, it felt like it. That's a good sign. So we were able to push the cases down together. So you can see how all the cracks are different from this side to this side. But you can see how this one was a common crack because it took a big hit on both sides. So that gives you an idea where the cracks are at. So when you start welding this stuff, you got to figure out where the aluminum's going to go. When you weld aluminum, it contracts. When it contracts, it can crack. If you weld up all one side only, it'll pull that way and it'll stay that way. If you weld up in both sides, depending on which side you do more welding on, it'll pull more one way or the other. So if you do more welding on this side, it goes this way more. If you weld more on this side, it goes that way more. So right now this is pushed out, so we need to do more welding in here. And we probably need to weld this first, which will pull this edge in. Then you come back and weld this, and you come back and weld this again. But see, this one here is not moved out. This one is. So this doesn't weld now. This one needs to be welded. And this one over here, same problem. More interruptions. Alright, more interruptions. It's one of those days I'm getting nothing done. Alright, so this is a very labor-intensive project, and it'll be several hours of welding without interruptions. It'd be nice, but I can see that's not happening for a while. But anyway, so to weld these things, you got to figure out what rod you're going to use, how you're going to weld it, the procedure you're going to weld it, how much you're going to V it out before and after you weld it. Obviously, you can't weld it all the way around because the case on top of it, you don't have access to welding here. So your access is out here when they're bolted together, and then you take the case apart and you weld the other half. That's usually how you do it. In this case, this one's pushed out, so I need to do some welding right here. Pull this in a little bit. Then I come back and you weld this. Then I go back over here and V out some more and weld it some more. But the problem is the push out is not right here, it's only at the very top. So I think I'm going to leave the welding on the outside first, and then I'll do the inside later. Like I said, welding this part of the case is not the problem, it's just this up here. So, because nothing's moved out past that crack. That's where it's moved out. So I'm not sure how I'm going to do that problem. And this one over here, it's the same issue. So I'd rather get a lot of weld here on the outside done and let it cool. And put some tension on the case. So when you go back and weld in here, it'll equalize the pressure in the case and not stress this area, because if you start stressing this area here, and if that crack goes through that fillet and starts heading this way, it really gets hard to stop. So I prefer welding from the outside first. We'll have to see what's going to happen. It's one of those deals. Now for the welding rod, I got several ones I use. We got the 53, 56 hard rod. I got the 555-6, which is a hard rod, but it's military grade. And then we got some 40-43, which is this stuff here. 40-43. That's this stuff here. So that's your soft rod. So hard rods have very, very bad cracking problem with elevated temperature. That is anything over 150 degrees. Everything about a motorcycle is over 150 degrees. In the real world, this is the rod you use a lot of because it works better than the soft rod. This is cast aluminum, and all the welding instructions is for billet material. We're not welding billet material. We're welding cast crap. That is all full of Harley Davidson muck. So this is nice, filthy ass aluminum. So I use different materials. If I'm trying to get a firm strength build up, I used a hard rod, especially I'll use this real fast one here because this has the most tensile strength. It's 55, 56 stuff. This has got like 30,000 tensile. The hard stuff's got like 27 or 8,000, and the soft over here's got like 22,000. So that's before you contaminate them with this. They get lower after you contaminate, I'm sure. Now, if you got to do any machining, you use hard rod. If it's all cosmetic, you use soft rod. Soft rod is real gummy, does not grind, cut, or do anything very well. The cosmetic color is slightly different than the aluminum here. The hard material is actually more color matched, but they both work pretty good. The soft rod works good for doing major buildup areas, and then the hard rod, wherever you got a machine, we use the hard rod. So whenever there's a bolt hole, a surface area that has to be machined, you want to make sure you're using hard there. So you can use soft down in here to make it stronger. More interruptions.